Alright, let's try for a super short, super simple video this time. To start out, my wife wanted a little bit more lighting for the desk in her office. So I pulled out a roll of this 12-volt LED strip and stuck it to the trim underneath the window. It's the same stuff I use for lighting in the shed. It's bright and it works pretty well. Now, the only issue here is that it's powered off of one of my bench power supplies. And I want it back. So here in the lab, we'll whip up a little desktop power supply that can vary the voltage to the LEDs. And hopefully not look too bad either. So I think for the case, I'll use this old parallel printer switch. Any of you guys out there still remember these? So I think I'm gonna clean this thing up, give it a new paint job, maybe drill a hole or two in the front, and cover up a hole or two in the back. And this should make a really nice and hefty enclosure for our desktop power supply. So I guess we can start by taking the guts out of this thing. This is awesome. All that's in here are 3 DB25 connectors, a rotary switch, and a whole rat's nest of hookup wire. All of this stuff is really useful and is probably going to come in handy in some future project. This whole assembly is nuts. I've gone ahead and counted, and there seems to be 81 connection points on this rotary switch, which is just insane if you think about it. And into the parts bin. Alright, now while the case is being washed and painted, let's talk about the circuit for this power supply. So I was thinking, what kind of circuit would be good at controlling an LED strip that runs at around 12 volts at say 1 to 1.5 amps? Maybe a 555 timer that's doing pulse width modulation and controlling a MOSFET. Ooh, or what about some sort of rotary switch connected to a whole bunch of big resistors so you could step through different current levels? But nah, totally overcomplicated. Here's what we're doing. We're going to start out with this 14-volt power supply that I found in my box of power adapters. We'll then feed that into a 7812 voltage regulator, which will spit out 12 volts. The output rail then connects to this LED strip, and we've added this 100 microfarad capacitor to smooth out any ripple on the output. Ah, but what about this common pin here? Well, it turns out we're going to play a little trick on the 7812. See, no matter what the input voltage is, the output always tries to get to 12 volts, with reference to the common pin. Normally, this is connected straight to ground. But by making the reference point somewhere between ground and 14 volts with a variable resistor, and giving it a bit of feedback from the output, we can create a sort of virtual ground that sits above the actual ground level. So basically by limiting the current flow into the common pin, we can end up adjusting the output voltage. I mean, it's kind of a hack, but it's also in the datasheet. And fortunately, the circuit has proved to work pretty well. Yeah, it's controlling my bench lights. Here's the circuit completely built up. We have our 14-volt input voltage here, the output for our LEDs here, our on-off switch on the front, a potentiometer, and our voltage regulator, with supporting components right around it. Now let's just put the case back together. Yeah, the clear coat really messed up the finish, ironically. And yeah, that's the box. So then I took our new power supply upstairs, plugged it into my wife's LED strip, and got my bench supply back. I even thought this project was neat enough to make a miniature version for my workbench. And hey, look, the project's all done. Take care now.